This presentation is about the ZEPROM and the ZVC Replica. I'm going to go. Okay, the ZEPROM is a module like that. We're going to see it later. It's a module that you can reprogram that was released in the end of 1980s. That today the equivalent of this is the Clonix module or the NOV module, but mostly the Clonix module. But this one is in 1980s, and that it was almost the only thing that you could do if you want to write your own program and have it on an EEPROM. Okay, and this is really to introduce the programmer of that program, that module, and it's that. That's the ZVC Replica that's replacing the original ZVC. So this is the talk about, the talk is about this. So you got the ZEPROM, the ZVC module, the original here, and the replica from Diego Díaz. Here. And a module, a ROM that you need in order to program the ZEPROM. And I have example how to configure and program the ZEPROM. So the thing is that the ZVC, this, is no longer available. You cannot find this. And it goes from collector to collector. And originally, it was available for about $60. Now, if you want to buy it like that, it's going to be between $500 and $1,000. Okay, because you can't have it. And the thing is that the ZEPROM, you can find it on eBay as often as a surveying module. And if you don't need a surveying module, you can erase it and reprogram it. But the problem was that you need that to reprogram, and that costs a fortune. And it cannot be found. So I talked with Diego, and Diego says, I asked Diego, since I had the original, can you make a replica of this? And he told me, yeah, I did that 10 years ago. And he never published it. Never said, oh, I did it, okay, done, put it in the drawer, and that's it. So he took that, reused the power supply that he did for the battery that he just released, and create this module. So this module is available for 50 euro if you don't have the connector at the bottom. If you send him and if you want to have a full one with already soldering and everything, it's going to be 80 euro. But if you have your own module, it's going to send you the PCB with everything. You just need to solder the connector, and it's cheaper. ZEPROM module are available on eBay often. Often they get disguised as a surveying module. And one of the things is that that's exclusive to the ZEPROM. You can use your code bank switching. So you can write an RPM program, and the module support bank switching. So we can have a 16K program fitting into 8K space, and you can do bank switching. And that's the only one that can do that. No, the Clonix doesn't do that. The NOV doesn't do that. Nobody does that. And the bank are persistent. If you switch a bank, you can put the calculator off on, the bank will stay selected. And the other doesn't do that. Each time it goes into light sleep mode, it will switch to bank 1 all the time. So this, again, is only the ZEPROM that does it. And also, it almost consumes nothing. Since it's an EEPROM, on sleep mode, it's consuming 3 microamps. So yeah, that's again Clonix or NOV is not able to do that. But sure, Clonix and NOV is way more flexible and more powerful than a ZEPROM. So it's a give and take. Diego Díaz made the ZVT replica, so thanks to him. Okay, the ZEPROM. ZEPROM is the module. You erase, you put, you have to know if it's the one, you got a small hole that you have to uncover to put into a UV light, and you're gonna erase it with that, and then you put something over it after that when it's programmed to keep your program in it. The ZVC, the ZEPROM has all the electronics to program itself. It just need the 12.5 volt in order to do it, and that's what this module is doing. So it can be, it fit into a HP41 case. It was introduced in 1987 at $135 US. And it can be configured in 4 modes. Straight 16K, bank switching 6K, bank switch 12K, or straight 8K. That's the 4 mode you can do. So if you put the ZEPROM into port 1 or port 2, it's gonna, in a straight 16K mode, it's gonna take the 4-page A to B. And if you put the module into port 3 or port 4, it's gonna take the 4-page at the upper end.
No matter how many times you look at this chart, it screws you up, and it's the only module that does this, so you need the manual. It'll mess you up when you try to do it. Because how it behaves is totally dependent on which port it's plugged into.
Exactly.
But the 41, the Clone XD does the same.
Most people don't know that.
Okay. You can, when you program it in the bank switching 16K, you're going to have core 0 and 1 into bank 1, and when you switch to bank 2, it's going to be core 2 and 3. Okay, and the same for, so when you plug into port 1, previously you were taking 4-page, now you're only taking 2-page, but it's bank switch. You got a 12K configuration. 12K configuration is like the Advantage ROM. The ROM at the bottom, the 0 and 2 are identical, okay, and 1 and 3 are different. So it's like an Advantage module. It's like that. And in an 8K configuration, core 0 and 1 is identical, and 1 and 3 is identical except for 1 byte. So it's a near clone. So you can, so that's the difference between each mode. The ZVC and ZVC Replica, it's basically a voltage converter, takes 6 volt and bring that to 12.5 volt. That's the only thing it does. And you have a switch that you activate here that, in the case of the replica, if it's on the left side, it's off. You don't have a LED, so it's in 6 volt. It's if that mode is a pass-through, and then when you put on the switch on the right, it's 12.5 volt, and it's in programming mode. And even if you have a bank switch module, it's going to make it flat 16K in order to be able to program. So that's the original one at $60. That's you cannot buy today. And that's the new one, the ZVC Replica. ZEPROM, what you need to program this is you need the EPROM, the ZVC Replica, and a software to program it, to write to the EPROM. Zengrange create that ROM. It's called the programmer ROM, and you can. It has all the function to program that ZEPROM in it. And yeah, that's basically it. Erase. You need a UV light eraser. It's easy to buy, cheap. Don't think that will work, but yeah. It takes about 20 minutes. You put it there, 20 to 30 minutes. You put it there, and then it's going to be erased. The programmer ROM. The programmer ROM was never released as a ROM. It's as a module. It was inside. When you bought the ZEPROM, each ZEPROM was erased, and then the last core was the Zengrange put the programmer ROM in it. So each ZEPROM had the programmer ROM burned in it. Okay, what the programmer ROM does is compiling and using user code. So it can take the user code program you're gonna pack it before, and then it can compile all the go-tos and labels and execute, and everything is gonna fill everything in your program in order to be able to put it in the ROM. Because those, if you want to have the maximum efficiency, all the go-tos and execute needs to be calculated and put in that function. So you're compiling your code. It can also do initialization and checksum calculation of a ROM. You got code and a function that will generate code that allow you to do user code bank switching. This is the only ROM that gives you that capability. You can copy a page, a 4K page from MLDL Rambox to the ZEPROM, or vice versa if you want. And you can copy a 4K from an MLDM, whatever, to a ZEPROM to an HPIL mass storage, like a cassette drive or virtual cassette drive. Or vice versa. You can take an image into a tape drive and program it to the ZEPROM or MLDL. Those are the functions that are part of the programmer ROM. And yeah, I'm going to go over it because we're going to see it later. Setup. What you need to do that, you need to 41, a ZEPROM module or several ZEPROM modules, depending on. You need the ZVC of the ZVC Replica. You need the programmer ROM. Originally, what you will do in the 1980s when I was using this, I bought always, the first time you bought two ZEPROM because you're going to erase one and you're going to use the other one with the programmer ROM inside with it, and you're going to plug into port 3 and you got to plug into port 1 the erase ZEPROM. So that today you cannot. There's all the ZEPROM that you're going to buy will have a serving program or something, and the programmer is no longer there. So in order to simulate that, you're going to use a Clonix module that you're going to put the programmer ROM in it, or you're going to use a MLDL box or a Max module or something that has QROM in it, and you're going to load that ROM image into that device. Or what I did is to basically reprogram a ZEPROM with the programmer ROM in it. So that's, and you need a computer. That's what you need. On the software, well, in this presentation, I wanted everything to be self-documented if you want to do it. So everything is command line oriented and everything is Unix style. So you got, if you want to have Unix command on Windows, you need Cygwin. On Mac, you need, for some package, a package manager called Homebrew, and Linux has already built in. And this is all the software I use. Now, on Windows, you don't need to do that if you don't. Because I need that in order to change byte in the ROM file. So you can use any X editor if you want and directly edit the image if you want. But in my case, I want the document to be self-contained and and so everything is explained there. This is how to do it. I'm going to skip because the presentation is made as you read it offline and you do it yourself, so all the steps are there. Basically, here at the right, here, I'm fetching the ROM file from Monte site where you get all the ROM file. And I'm using this to get the programmer ROM. Here I'm showing how to configure hpcalc.org and all the screen. Okay, flat. If I want to, this is an example one. We have 3 examples: a flat 16K, a flat 8K, and bank switching 16K. So this is a flat. Let's say I want to have those 4 ROM loaded into the 4 core here. Okay, so I need to fetch that ROM. Those ROM came from the file that I download from the Monte site. Okay, what I will do here, my setup here will be to have hpcalc running on a machine, and I'm going to have the pillbox and hpcalc to transfer the ROM image into the HP41. And on the HP41, I will have the ZVC and with a blank EEPROM, hpcalc, and the programmer ROM. So, and these are the port, and these are the page where they're mapped. So again, command line. Here I'm creating a virtual tape, okay, and I'm adding the ROM to the virtual tape. And I'm exporting that, and I'm loading that into LIF hpcalc, and then if you see that this is the virtual tape that contain all the ROM with the in eRAMCO format. So this is using the LIF utilities. LIF utilities allow you to create LIF file, compile HP41 codes, create raw file. You can do all the things that you need to do with LIF and HP41 with those utilities, and it's available free, and it's running on Mac, Linux, and Windows. So I'm on the then on hpcalc, I'm loading the file, and I see this. That's the virtual volume into a virtual tape drive. Showing how to do this here. So on the 41, what I do is I insert the ZEPROM. I have the ZVC, the ZEPROM. I'm putting the programmer on. And I have into the 4th page the programmer ROM also in the other module inside the HP41. And these are the commands that I have to do. I'm putting in alpha the first ROM image, the name of it, the page, destination page, and I'm saying IL burn. So it's going to take the ROM image from the tape and burn it into the ZEPROM. And I'm doing this for all the 4 ROM image. When it's finished, I switch back up the ROM. And I can, at that point, I have burned the ZEPROM, and I can use it. So that's all there is to. The most complicated thing is to create a virtual tape and put that into hpcalc, because at that point, you have only 4 times the same command with the 4 ROM image to load. So that's it for this mode. Bank switching. HP41 bank switching can support up to 4 banks for each page. You have 4 commands. You have command here. That's instruction. Enable bank 1, 2, 3, and 4. Now the ZEPROM support only 1 and 2. 3 and 4 was defined by the HPACs after that, later on, and ZEPROM was released before the EPAC, so it didn't support it. And you have one command to support also is write MLDL. That's another command that's understood by the ZEPROM and all the MLDL boxes. So that's the command that's used in machine language to burn a word into a device, either an MLDL box, a RAM box, an EPROM, or so on. So you need that at the lowest level in order to be able to write to the ZEPROM. Now, the HP41 doesn't, the OS of the HP41 doesn't support bank switching, has no clue as to what is a bank switching. So this came later on, way later on. So so how they implemented that is that the CPU, all the opcode of the CPU was not used. Some of it were no operation. They didn't do anything. So they used those, those NOP instruction, and they used 5 of them, and they define to do it something different. But that is not understood by the CPU. It is understood by the peripheral connected to the HP41. So each command, each instruction that goes into the 41, in the CPU itself, also goes on the bus. So the instruction goes on the bus, the CPU sees it, does nothing, and the hardware connected to it sees it, and it does something. So the peripheral does something, the CPU does nothing, has no clue as to what's happening. That's how it's implemented on a 41. Now the ZEPROM, again, that's another one. The bank switching on the 41 was not standardized. Since it was not defined by HP, people start defining them. The people means the manufacturers of the chip or whatever, that's the peripheral that was, they defined them themselves, and they did not talk to each other. So CMT was the first one to have bank switching support, and they did it their own way. Second one with HP was with the Advantage ROM, and they did it a different way. CMT was pissed off when they learned that about the HP. Since CMT was created with ex-HP employees, they were able to talk with HP, but they didn't share that information. So, and when Zengrange released their ZEPROM, they did it like HP did on the Advantage ROM. So that's why the ZEPROM is compatible with HP way of doing things, but not the CMT. So how they do this? There's a special, there's 4 bytes, 4 words near the end of the 4K ROM that there's a one that you need to do, and then you have to play with the bit in order to say it's bank 1, bank 2, or HP way of doing a automatic band switching like HP does. So this is why we need to modify the ROM in order to set the bit. So this is an example of how it's working with its setup. You got the ZEPROM, you can have a ZEPROM, a ZenROM, a second ZEPROM, and the first one is going to call the enable bank 2, and this one will switch to bank 2, but if you have another ZEPROM, it will not switch to bank. And the last one, if you switch bank to bank 1, the first ZEPROM is going to switch to bank 1, but not the second one doesn't do anything. Flat 8K, you got the same, this is how, what you do is you want to use the same ROM, because you want to use, you have 16K and you only want to use 8K. The thing how to do this is to put the same ROM into core 0 and core 2, and the other ROM into core 1 and core 2, and say to the ZEPROM, use bank switching. So how you do this, this example, we'll use a Zen ROM, the same ROM image for core 2 and core 0, and I'm going to use a programmer ROM here, and I'm going to clone that programmer ROM and set the bit of the first one to say that's bank 1, and send the bit for him to send bank 2. That's how you do this. Same setup as before. Now, this is what it does, is basically going into one FFA with the good address and switching the bit to here. I'm switching the bit to 1, and I'm validating that it's the bit, it's before it's 00B9 and after it's 01B9. And I'm doing the same for the second one here. 00B9, it became 03B9. So we have bank 1, and well, if you look at here, second bank, the 2-bit must be 1, so it's 3 in binary. So now how you do this? Create the same virtual tape as before, but now I'm adding the same ROM image for lower page and the upper page as the 2 ROM modified. And you do the same as before. You loading the ROM image, and at the end, what you have, instead of a 16K flat, you have an 8K 2-bank, but actually you're losing the second way 8K. But why you do this is that you only want to have 8K and you don't want to use the upper 8K. It's using bank switching, but you don't use the bank switching. You're using only bank switching to put it into an 8K, and that's it. Third, user code function. That's part of the programmer ROM. What you can do with this, you can verify if the EEPROM is blank. You can init an EEPROM, a ZEPROM. You can add the bank switching, the low-level bank switching code, and you have to, again, add machine code, bank switching code, and user code, bank switching code. This will add function that will do the bank switching. I'm putting here what it adds to what address and how the function is there. And how the bank switching works on user code. This is only programmer ROM, and this is only working on ZEPROM. Here, they had a bank go to, bank execute, and bank return. And the number here is the XROM number. Okay, so you have 4 ROM. Each ROM has to have its own XROM. And when you call the programmer ROM, it's going to generate those functions with the ZEPROM, and it's going to add the logic in it. The logic is if you use a go to or execute or return, it will always activate the second bank. So, and if you, on the lower page, on the upper page is always going activate the primary bank, the first bank. So that's how those function works. Okay, so, and we're going to see an example after that. This is undocumented. They don't explain that in the manual, and that's why nobody's has used that in the 1980s. It took me hours to figure it out. And I think I erased 10 or 15 EEPROM, ZEPROM, and reprogrammed it until I fully understood that was the pattern. Then in the programmer ROM, you got the function that you're going to use to compile user code and find the program length and the number of alpha label. That's important because you need, when you create the FAT, the function, the number of function at the top, you need to reserve a certain space, and for each program you need to get how much label you have and the space. You got the function to burn into the ZEPROM, the checksum of the module. That's it. Yeah.
What would the checksum normally be used for?
It's only used. It's only checked by the diagnostic module, so it's an optional. You can do it if you want, but it's only for a diagnostic module that validates that. Basically, all the HP module has the checksum correct, and all the other modules, well, it's a give and take. It's some have implemented the other. It's a good practice to do it. I do it all the time, but it's not everybody's.
It drives me crazy the 42S doesn't have a checksum.
Yeah. So this is how the structure of the 4K basically is done. The header, the trailers, this reference information. Bank switch. Again, same setup. Now, this is a user code that does not big thing, just show a message and does the beep. But each program is in a different page and in different banks, and everything called the other. So this exercise the logic of how the bank switching works. And basically what I'm doing here is that and how bank switch those function works is that you have to put the label into X. The alpha label need to be into X, and it's going to call that and do and execute indirect X alpha by X, and it's going to do the pace switching at the same time. So what it does is here, and I'm calling bank switching, putting user code function and execute bx code 02, and here 02. Will always switch to bank 1. So I'm in bank 1, but I'm calling this, and it's going to switch to bank 1. That's the same bank as this one. So it doesn't do nothing. It's going to load that and do a B return 02. It's going to stay in the same bank because 02 is, if you look at here, is going to stay in bank 1. It's going to come back here. And if I execute do recall 00 is U2 display, and do execute 01, 01 here will switch to bank 2. So it's going to switch there, do this, and it's going to go, if I do execute go to 03, it's going to go here, and 03 is always switching to bank 2. So it's already in bank 2, it's going to stay in bank 2. And when I'm going to do bank return 04, well, 04 will switch to bank 1, and then it will switch to bank 1 and do a return here.
Now, the bank switching is kind of automatic.
It's not, this is not transparent. This is what you're doing. The function here is doing, you're calling this, and is doing the bank switching. Right. You need to understand this behavior to make this work correctly. But if you do, then you have a 16K user code that fit into 8K space.
So you have to keep track of what's in every bank.
Sure, you have to plan this.
Oh, okay, right.
Okay, that yeah, you have to plan this. You have to understand how it works. But it's the only module in the HP 41 world that does this.
Yeah.
Okay, so for this is interesting. So it also means that if you use 4 ZEPROM in the 41, you could have, instead of 32K of user code, you could have 64K of user code fit into a 32K space.
Now, how many HP did this?
No, not HP. This is Zengrange who did this.
Oh.
This is
because they wanted to get more.
No, but the Zengrange decided, I'm not the product manager of Zengrange, okay, but they did two things. First, they did the same bank switching as HP, and they add their own option to have a persistent bank switching, okay, that nobody did before and after. And also they decide to write their own program to allow user code bank switching that was never allowed, and nobody did it before. Okay, so this is user code bank
But
switching.
this is 20 years later.
Yeah, still today. But why it's not implemented into Clonix and Ovi and the other is that nobody knew that. This is new. This is because me scratching the things and trying to understand, and I uncovered this, and I was not even aware that this was the case.
But what triggered that for you?
Well, I want to show tell people that the ZVC replica existed, and then to do that, I need to use the ZEPROM. In the 1980s, I used the ZEPROM, but with M code, and M code is another story. You don't care because you fully control the thing. Okay, but now to user code, the behavior was not this. It had a behavior that did not understood, because I understood everything, all the other pattern on the product on the HP41 about bank switching.
So you climbed the mountain because it was there.
Yeah, well, it was unexpected, and then I had to yeah, and this was like new, and that's it.
Contribution.
So this is the program that I did, and also how to this is how to do it. So, and this is the step. The step to create that is more complicated, because when you do a user code, you need to you have to create the header and then add the code switching, and this is like a loop for every program that you want to load into the ROM. You specify the ROM, read the program from the tape, and then transfer that into the ZEPROM. And when this is finished, you do the checksum, you burn, and then you save it to the tape. So you do this for all the ROM. One thing is that the ZEPROM, with the 12.5 volt, the 41 is at some time unstable. So it's gonna crash and gonna create all kinds of things. Not when you burn an EEPROM, but if you let it to 12.5 volt very long time, it's gonna have a drag on the battery. So what I do is basically I create all my ROM into an MLDL box. And then when everything is there, I save that into the ROM image, and then I take the ROM image and program the ZEPROM. It's faster and easier.
There
Yeah.
aren't very many of you around.
What?
There's not very many of you around.
So, not that many of what? Of me around, yeah.
The average 41 program isn't going to do this.
Yeah, I know it's like 30 years too late, but yeah. That's it. So that's how to do this. I put some, the price for the ZVC replica is €50 or €80 for a complete module. ZEPROM, you can find it on eBay price depending on the module.
Still floating around.
Yes.
You can get those modules really cheap, because 9 out of 10 times they're surveying applications that no one on the planet cares about.
Yeah.
Yeah. And why I did the talk is I found very sorry to have those ZEPROM unused, stay in the drawer with surveying that people would not use. So when you can erase it and buy a ZVC to program it and reuse that. Yeah. Diego doing all those, he's doing the ZVC replica, but also all those products. Those are the link for different manuals, and okay, the manuals of the ZEPROM. This is the original manual. Okay, it's available on Eric's site. He has a PDF version of it. This is explained in, if you want to use the ZEPROM, that's a good idea to go.
I had a bunch of those, and I just included that with everything I sold.
Yeah. Software that I use is the link for that. In the ZEPROM, in the drive, you're gonna have support a zip file with all the what I use in the presentation. Everything is there, so you can use it and experiment. Yeah.
So why would you want to use this technique or approach versus 41CL?
Yeah, I will not. Okay. Okay. It's a 41CL. You got everything inside. But if you have a standard 41C, okay, or CV or CX, it's interesting because you can. But again, 41CL doesn't support persistent bank switching. Because nobody knew up to right now who say that it even exists.
Sure.
Jim, one answer is you can make your own Advantage ROM cheaper than you can buy an Advantage ROM.
Yes.
Yeah, also, because most people, what they will do with this, they will not do their own ROM. They will just create a custom ROM. Not custom ROM, but they use the ROM image and burn their own module. And also this one, consumption is it's 3 microamps. It's very, very low. So it's way lower than everything else that exists today.
Okay, there's some advantage.
Yeah, there's some. The advantage is power consumption, user code bank switching, and persistent bank switching. But that I will expect Diego at some point, or Monte or the other, maybe to implement that option somehow. But maybe not. I don't know. It's them to decide what they're going to do with their own product. But today, that's the only one that supports persistent bank switching. So that's basically it. Do you have other questions?
These are available now, right?
Yeah.
Okay, thank you.
Okay.